Subchapter 4.5 Simple Cooling Load Calculation (CLTD) method. The analysis will be performed by using cooling load temperature difference method, or also known as CLTD method. This method can be said as a reasonably accurate approximation of the total heat gain through a building envelope that later will be used to select and sizing the HVAC equipment. For MEC351, we are going to use this cooling load estimation table template throughout our discussion. But before we can perform the analysis using the CLTD method, we need to identify in detail the characteristics of the condition or design space. It includes the drawing floor plan such as shown in the slides now. It is important for us to know the dimension, the cardinal direction, such as north, south, east, and west. And other characteristics of the condition space, such as the placement of the window and door for each walls. Other than that, as a good designer, we also need to carefully identify the information on our condition or design space. All the characteristics that is deemed important for us is recommended to be listed out in the table form. They are the room size. We might have the length and the width from the floor plan. However, it is crucial for us to know the ceiling to floor height of the condition space for our analysis. The information about the wall, such as the material used and the construction type. Next is the details on the windows, including the number of unit used, the size, the type, and other criteria such as the shading condition and the glass color. These details is advisable to be separated into each direction. The fourth item that we need to consider is the type of roof, if applicable. We also need to know the detail about the door for our condition space, including the material, number of units installed, the placement to which wall, and the dimension. Next is the lighting type and characteristic. For this, at least please make sure that you know what is the lighting type. For the lighting characteristic, we can retrieve it later from the table. We also need to know what is the purpose of the building. Whether the building is single-story or multiple-story. The location of the design space also need to be identified, such as ground floor, intermediate floor, or top floor. The floor area, the wall area, and the glass area. It is important for us to know which sides of the building are exposed to the sun and which sides that are not. We need to justify whether our design space is having ceiling or roof. Normally, if the design space located at the intermediate floor of a multiple-story building, they will have ceiling, while a top floor design space will normally having roof. If there are glasses placed to the design space, we need to consider the shading characteristics, such as whether it have blind or not, and the glass color. And lastly is the occupancy, including the number of occupants and the nature of work. Again, it is recommended to summarize all of these informations or assumptions for the space in the tabulated form. It is advisable for you to develop this table in order to segregate the information about the overall site area, glass-only area, and the wall-only area, especially if the design space having glass as part of the construction. Now, let's have a look at the cooling load estimation table template. First, we need to fill the information of the design space as follows. The usage of the space, such as bedroom, living hall, and etc. The operation hour of the design space, 12 hours or 24 hours. The size, length times width that give us the floor area. And the floor area times the floor to ceiling height, which give us the volume of our design space. Next will be the psychometric analysis table. There are three conditions need to be filled, which is the outside air condition, room design condition, and the difference between the outside air and room design condition. For each condition, we need to fill at least the dry bulb temperature and specific humidity for the ease of our analysis. However, if we have all of these properties given from the questions, it is advisable for you to fill for every properties. The outside air condition and room design condition will normally follow the ASHRAE 55 standards as follow. However, if there is special requirement for the room design condition, you may have to follow that requirement. Next, we are going to fill up the ventilation information for the design space. The number of people is the occupants for the design space, times with the CFM per person that will be retrieved from table 11. We are going to refer to the nearest application and select the recommended value. The result of this multiplication will give us in terms of volume flow rate in the unit cubic feet per minute, CFM. The square feet is the floor area that has been calculated previously, times with the CFM per square feet that will be retrieved from table 1 for the nearest application. We are going to choose the average value for the fresh air. Air change per hour is depends on the space application. We should refer to the guidelines for this. However, for MEC351, you may refer to the questions. If it is not given, then we are going to use 1 air change per hour, times with the volume of our design space that has been divided with 60. Note that all tables are available in cooling load estimation reference table.